İyi günler arkadaşlar. Dersimize başlayalım yavaş yavaş. İyi günler Tolga, iyi günler Arda. Bugün, okay, let's switch back to English. Today we will actually we have been discussing black box testing. I will make a quick review on the black box testing, and then we will talk about our little more complex example about print file. But before discussing that example, let's go through the black box testing quickly. Well, we said that we emphasized that black box testing is a functional testing. We have talked about this diagram where we assume that the program or software product that we are going to test using black box testing method is a black box. That means we don't see the structure of it, that we don't see the source code of it. Of course, we have the source code in our hand, and that would naturally help to testing this software product. But the principle of black box testing, that it's a functionality testing, dictates us that we perform this testing without using the source code. Okay, now let's look at how it works. We input x, and we get some value f of x, and this function should be implemented by the piece of code that we're testing. Well, if the actual output of the source code is equal to some expected output y that we receive from our software specification document, then we say this source code or this piece of code has passed the test. Otherwise,
if the expected output and the the expected output y is not equal to the output, the actual output, output that we get from the test, then we say that it failed the test and we go back, and that's a reason for debugging, looking for the bugs in the source code and debugging it. Okay, so this tells us basically that we test the system, we test the source code against the specification, against the specification document. All right. So then we talked about the principles. Well, we said that as in our discussion on the previous slide, we said that it is based on the specification. That is, we uh, we base our tests upon the requirements, technical plans and architectures, user manuals, etc. So code is not necessarily needed, that we also said, while it certainly helps, while we definitely have the source code, but the thing here is, the principle here, the principle of black box testing is that we don't use the source code to perform our testing. The general strategy applies especially to integration testing, system testing, acceptance testing, and we said that we mostly apply this testing to the functionally meaningful modules that may be functions, that I'm sorry, that may be subsystems, or that may be integration of subsystems, that may be system testing, or that may be acceptance testing. We usually don't, not we don't apply, but since the units don't have standalone functions, of course they are functional, of course they help as components to modules to fulfill their own standalone functions, but they by themselves don't have meaningful functions. This is defined by itself. All right. So that's why we usually perform unit testing using structural testing, which is the white box testing. We will pass to that. We will discuss this testing strategy also this week. I hope we'll start that tomorrow. But yeah, this can be assisted by a post-white box testing phase to obtain code coverage measures as indicators of test quality. Okay, so this last remark tells us that we apply a post-white box testing. That is, we apply a white box testing phase after the black box testing phase to compare the results of the black box testing with the white box testing, so that we can see how successful the black box testing was. Okay, we mentioned that we mentioned the domain partitioning. We said that we keep the system domain as the set of all input values, and then we partition the input values in equivalence classes, and we define actually our black box testing based upon the equivalence classes. We said that if this is all input values that we can present to this system that we are testing, then each of these are equivalence classes. Diagrammatically, we can show it, like, or pictorially, we can show that each of these is a separate equivalence class, and you see that the entire input domain both composed of both valid and invalid inputs are partitioned into some equivalence classes. And we will perform our testing using these equivalence classes. Now, what are the equivalence classes? Once again, they are um, set of input values that the test engineer believes makes the system behave in the same manner, in the same way. Okay, so this may be n equivalence classes where n may define a diversity of values. And well, equivalence classes, each of these oops, I'm sorry, each of these input instances, input values, we believe behaves the system in the same way, in the same manner. Okay, this is the most important thing about the equivalence classes. Now, how are we going to, well, let's look at the black box testing hypotheses one more time. Each value in an equivalence class results in the correct execution or in a failure when used as input to system. So that means, actually that defines the black box testing hypotheses. That means for testing purposes, one representative input value from each equivalence class is enough. Theoretically, one representative input value from each equivalence class should be enough to test the system for this equivalence class, because what did we say? We said that the each input value each input value in the same equivalence class makes the system behave in the same way. So then theoretically, one of them should be enough to test the system for this equivalence class. But in practice, this hypothesis does not hold all the time, because sometimes there may be some boundary values, etc., which may make the system behave in different ways, given the code of the system, of course. So that means in practice we shall test the system with several input values instead of one input value from each equivalence class. Okay, so now we continue with the equivalence classes after the after the black box testing hypotheses. Well, what should be the values among from the equivalence classes that we would rather like to test the system with? Well, of course, a typical representative of the equivalence class, okay, a typical representative input. So and these representative inputs here are denoted by black dots, all right, and some boundary values too, okay, some boundary values too. So that means we test each equivalence class with a typical representative input plus with several boundary values, all right? So that means in practical black box testing, each equivalence class is represented by a typical representative input, by a typical input, and by at least one or more boundary values. So keep these in mind. These are the summarizing principles of the black box testing approach. Okay, here we mentioned how we should test the boundary conditions. For example, open boundaries, closed boundaries, on-point values, off-point values, one-by-one domain testing strategy, etc. So for open boundary, we said that we should use one on-point and one off-point approach. And for the on-point value, we should look at the value outside the domain, that is, the condition should be false, and one off-point value, which is the inside domain, to check the condition where where the given value is true. For the closed boundary conditions, we should well, let me. I think I didn't give you this detail. Let me show you this. Well, this is an open boundary, for example. Okay, and this portion here is outside the domain, and this portion here is inside the domain. Okay, and let me write this too. Um, Let me write this too. Okay, here. Just to remind you, outside the domain. All right, and well. What we do here is we select a point. Oops, sorry. We select a point here for an open boundary. This is an open boundary. We select a point here, and we select a point here. Okay, and this point here is the off point, which is the inside the domain, but this is off the boundary. Okay, this is off the boundary, and this here is the on point test case. Well, since it is an open boundary, this value here is a test case that tests the system for a false condition, because here this is outside the domain. The boundary itself is outside the domain because it is an open boundary, because it is a strict it represents a strictly greater or strictly less condition. All right. So this is what we mean by an on-point and off-point approach. All right. For the same thing is true for closed boundaries. Okay. If the boundary is closed, that means this boundary is now within the domain. All right, it is inside the domain, so that makes a boundary value, on point value, a true value. All right, because the boundary, the line, the limit of the set is within the domain, right, inside the domain. So then the condition, the test case is true. All right, so on point, then an on point value tests the system for a true condition. All right. On the other hand, we will also use an off point test case, but this time we will use a point. We will use a point that is outside the domain. Okay. So this here, since this is outside the domain, this is not within the set that we are testing. This point will represent an incorrect, a false condition. Okay. Do you understand that? Do you understand that? Please, can you give me an explicit point that you do or you do not understand what explained you on this slide? Because this is important from the testing purposes. Please give me your suggestions, whether or not you do understand. Each of you, I wanna see a message from each of you people that listens to that lecture. All right, please give me your answers. You do understand what I talked to you, or you do not? Okay, I wanna know from each of you an answer, because this I will also use to see that you actually listen to the lecture. All right. Okay. For uh, for Tarkan, I would like to explain the thing again. We are talking here about boundaries, how we're gonna test them. All right. And here, well, for open, when we test an open boundary, how am I going to test it? Using one on point and one off point test cases. So we're gonna test, for example, an open boundary using, well, what is an open boundary? Let me go back. Well, open boundaries are boundaries with strict mathematical operators. All right. Less than or greater than. So open, when we say we test open boundaries, we actually test less than or greater than, but strict operators, less than or greater than. So when we're gonna test such operators, then that means we're gonna test them using an on point and off point test cases, using two values. One is on point and one is off point. When we say in open boundaries, when we say off point, I'm sorry, on point, we mean we mean a point exactly on the boundary. For example, if x is less than 3, then I mean this line here represents 3. Okay, Tarkan? That means if I test the system using an on-point test case, that means I use 3 exactly. Well, if x is less than 3, then is 3 within the inside the domain or outside it? Well, if x is less than 3, then it is outside the domain, right? So that means if I test the code, if I test the system using the value 3, then since I test x less than 3, x less than 3, all right, and since this line here represents 3, okay, then this is a false condition, right? This condition is false. Why? Because this condition is true for all values that is strictly less than 3. But if I test this piece of code using the value x equal 3, then this condition becomes false. Do you understand that now, Tarkan? Okay. So well, I assume that I took an answer from everyone, so that means I will continue, and the others, if there are any, are not listening. All right. Um, okay. Now about the non-scalar type, we will test non-scalar types using one on point and one off point, two test cases. That is all right. One on point and one off point. And non-scalar types are enumerations, booleans, strings, complex numbers, and one on point, that is on point test, will perform a test for true conditions, and off point test will perform a test for false conditions. All right. So well, we will see in the example how that is performed. Uh, let's see. For example, for a range of values, two boundary conditions. Well, we will test the conditions where a value is okay, where we have actually a piece of code which checks for the number between A and B. All right, we're gonna check an integer between A and B. So how are we gonna test this? We're gonna test this for value for two on points because we have two conditions. Okay, these are closed, right? These are closed boundaries. So for each boundary, for each closed boundary, we're gonna test using one on point and two off points. So for this one on point, two off points, and for this one off on point and two off points. On point will be within, that is, x is greater than or equal to a. So on point A is tests a condition for true, and on point B tests a condition for true. And off point A minus 1 tests a condition for false, because the condition is x is greater than or equal to. So A minus 1 tests a false condition, A plus 1 tests a true condition, x less than or equal to B, so B minus 1 tests a true condition, and B plus 1 tests a true condition. So we had two closed boundaries, so we tested them with each with one on point and two off points. One on point and two off points. Okay, so strict inequality operator, this is an open boundary. The example is integer x shall be greater than a, or we are testing this here, x is greater than a, where x is an integer. So we are going to test this condition using one on point condition, which is a false condition, and one off point condition, which is a true condition. Right? So so these are examples. Well, we have given further examples for specific values, one closed boundary condition. For example, value of integer x shall be a. It is equal to a. So on point is a true condition. On point is a true condition. Well, if this is the condition, and if I test this condition using 100, then it is an on point test, and it represents the true condition. And I test this here with 99 and 101, and these are then both false conditions. All right. Okay. So well, for set of values, let's say example is weekday x shall be a working day. That means I'm testing whether x is within within this set or not. On point test would be Friday, for example, because this is within the test, and off point would be Saturday, which is not within the set. The Boolean or non-scalar type, just like this one here, if I'm going to test a true one, for example, if x or if 0, then on point test will be a true condition, will test a true condition, and off point test will test a false condition. Okay, then we introduce the category partitioning method. Category partition method is the method for is based upon the equivalence classes, and it has 6 steps that we have discussed. specification of input categories. So here we extract or specify the input categories or problem parameters. Which parameters are we going to test? We are going to specify these. And then we are going to divide each of these problem parameters or input categories into equivalence classes. Okay. For each of the input categories or problem parameters, we will think of equivalence classes. That means we will think of different ways that the values of this problem parameter may make the system behave in different ways. Okay? Then we will specify the tests, and in 4, 5, and 6, these are the steps of the category partitioning method, which are implemented, which are performed automatically. That is using a tool. Fourth one is the generation of test cases for the test frames into executable form. That is, we convert these tests into an executable, and we combine these into test suites. And then we store this testware into a test database. Then we test the unit by the test cases. The unit may be a module, a subsystem, a system. By test cases, refinement of conflicts, choices, maintenance of test database, etc. These are all performed using automatically using a test tool. Okay, then we discussed an example, array sorting example, and we applied the category partitioning testing method on this array sorting example. Here we here we specified the input categories for array sort example. We determined that size of the array may be an input category, type of elements may be an input category, maximum element value may be an input category, minimum element value, position of maximum element in the array, and position of the minimum element in the array. These may all be input categories for this example. And then for each of these, we have to perform in the second, this was the first step for the example. In the second step, we are going to specify or determine the equivalence classes for each of the input categories. This we did for at least the size of array. Here we said that one equivalence class may be that size is equal to 0. Another one may be that the size is equal to 1. Another one may be a group of numbers where size is between 2 and 100 inclusively. Another equivalence class may be that all numbers that are greater than 100. And and another one may be an invalid or illegal size, like, for example, a percentage sign. All right. In the third step of the testing strategy, we build test cases. All right. We build a set of test frames using a set of test cases. A test frame is a set of test cases, and we perform several test frames. So an example to building a test case for our array sorting example is, for example, for the input category size of array, I choose an equivalence. I choose the equivalence class, the third equivalence class, and I select 50 as the value out of this equivalence class. since I see 50 as a typical representative input to this equivalence class of the size of the array category. For the type of elements category, I select a integer as the only valid equivalence class. All right. For the maximum element value, I choose 91. For the minimum element value, -3. For the position of maximum element in the array, I choose 15. And position of the minimum element in the array, I choose 43. All right. So all these are the values out of the equivalence class of each of these input categories. These form a single and unique test case. Okay, and then I should perform 4, 5, and 6 steps 4, 5, and 6 using a testing tool automatically, where I generate the test cases into an executable. Where I generate this test case, for example, that I prepared here for the test variant into an executable form. Then I store this test variant into a test database, and then I test the unit using by the test cases, refinement of conflicting choice, and maintenance of the test database. So, well, these are, again, these last 3 steps of the testing strategy are performed, using a testing tool automatically. All right. Now, this is an example. This is the example. This is the example for the prepared test case I just discussed. I showed it diagrammatically, and I show here, for example, from the size of the array, I chose 50. So I select the representative input out of this equivalence class from this input category. And I select from this input category, from this equivalence class, this value. Actually, as a matter of fact, this is the only value in this equivalence class, all right? And out of this input category, I choose from this equivalence class the value 91. From this input category, from this equivalence class, I chose -3, etc., etc. So each of these selected build a test case, and each of these build a test frame, and these are the choices or equivalence classes, all right? And each of these are input categories or problem parameters. So do you have any questions? Please, if you have any questions, raise your hands or write to me from your chat panel, or okay, you can ask your questions if you have any so far. Please, if you have any questions, let me know from the chat panel so that I can unmute you and you can talk. Do you have any questions? Okay, these are important, so I hope you understand them. Since I don't see any questions, I should assume that you understand them. If you are afraid to ask questions here, please write to me through the email, either through your group email or from my private email, and please do ask questions. Okay. Then we gave this example, the find string example, okay, using which uses this is a typical find facility in your word processors or under Unix. This one, for example, is used under Unix. And given these four arguments, this facility finds this specific text within this document using the direction you specify and regarding whether or not the search is case sensitive. Again, regarding what you have specified here. All right. So we have prepared testing for each of these, but first we have selected the input categories. We said that each of these arguments is a input class. I'm sorry, input category, and for each of these input categories, we have prepared equivalence classes. For example, for the input category text, we have prepared 1, 2, 3, 4, 5 equivalence classes. And for this input category direction, 2 equivalence classes. For match case, another 2 equivalence classes. And for the document, another 2 equivalence classes. And if you remember, I asked you guys how many different test cases should be prepared given the provided the hypothesis testing, black box hypothesis testing, and you multiply the values 5 with 2, 5 times 2 times 2 times 2. So you multiplied the equivalence, the numbers of equivalence classes at each input category, and you correctly found out 40 test cases. 40 test cases. All right. So, and we showed that slide that the numbers of equivalence classes are multiplied all together, and then we can find the number of the theoretical number of test cases that we have to perform to test this piece of code fine. All right. And we actually did that. We prepared each individual test case here, and we showed that here, these 4 test cases, and each of these we have discussed in the previous class, if you remember. Well, that brought us here. Well, and we left off at this slide here. This is another example we said. This is a print file example, and this just as the find facility in the previous example, in our previous example, this also has 4 input, 4 arguments, and each of these arguments we will accept as input categories or problem parameters. All right. And for each of these problem parameters, we will extract our equivalence classes. For example, for name of the file, for the number of copies, where n is the number of copies between 1 and 100 inclusively, and the default is 1 if we don't write anything. If we don't write this, add this identifier into the command line, then in default will print one copy. Minus FKM, F stands for font, and K is an enumeration that specifies fonts. We have that that shows us that we have 9 different fonts like Time New Roman or Courier or Tahoma, etc. And M here is a mode for either normal or bold, okay? And the defaults of the fonts is 1, the first font, and for M, the mode, the default is the normal font. And here the last argument specifies that whether or not we have to paginate, we print the document in pages, in form of pages or not. Okay, the default here is that the pagination shall be done. If we add this identifier minus NP, then that means we shouldn't paginate the printing. So this is our example. Now we will we will discuss this example from the black box testing viewpoint, how we're going to test this using the black box testing strategy. But do you first, would you please tell me if you understand what's going on? Do you understand the example, first of all? Do you example what we are going to test using the black box testing strategy? I would like you all to answer me. I would like you all that listen to me will to answer me whether or not you understand this given example. What is this example? Do you understand that? Okay. This is all of you people. Yeah, please give me your answer so I can continue, or I should let me know if I have to explain several portions of it. Yeah, go ahead. Okay. All right. Okay then. Well, the first thing we need to do is to find out the input categories, and we actually found out the input categories that they are each of the arguments. So we have 1, 2, 3, and 4 input categories: file, the file name, the number of copies, the font, that is the font type, and the mode of the printing, and finally the pagination. So we have 4 input. Actually, we have 4 arguments, but we have 1, 2, 3, 4, and 5 input categories, because at this third argument we have 2 different input categories. Okay, and then out of these input, for each of these input categories, we will extract the equivalence classes. This is the second step of the domain partitioning testing strategy. Okay, we will do the extraction of the equivalence classes for each input category tomorrow. So See you tomorrow at 8:30 in the morning. Goodbye now.